everybody, welcome back to our 12.3 video lecture. So we're going to pick up exactly where we left off. We'll pick up in example 2, which is about evaluating logarithms. So evaluating is just performing operations, and you should end up with just a plain number at the end of it all. So when it says to evaluate log base 12 of 12, what I would think about is 12, which is the base, raised to what exponent gives me the 12 that it's taking the log of. So 12 to the first gives me 12, which means that the log base 12 of 12 equals my exponent of 1. Okay. Same thing for part B. So I've got the base would be the square root of 3. And I'm thinking, what exponent does it get raised to give me the square root of 3 that's inside of it? Well, the square root of 3 raised to the first power is the square root of 3, so that means that the log base square root of 3 of square root of 3 equals 1. Let's do another one. In part C, we've got log base 3 of 1. So in exponential form, I'm thinking 3 to what power gives me the 1? Well, anything to the 0 power is 1, so 3 to the 0 equals 1. So when it has evaluating log base 3 of 1, it's going to equal my exponent of 0. Last one, log base 10 of 1, same thing. I'm going to think 10 to what power gives me 1? Well, 10 to the 0 is 1, so that means that log base 10 of 1 equals 0. So that's how you evaluate logs, and obviously all these are 1s and 0s. You can certainly get other exponents when you're evaluating. And exponents can be positive, they can be negative, but that's how you would do it. Is I would get them in exponential form first, okay? So a couple of properties that we were seeing. So whenever you have the log with the same base as what you're taking the logarithm of, so this is what we were seeing in example A and example B, log base 12 of 12. Log base square root of 3 of square root of 3. Whenever you have the same base as what you're taking the logarithm of, you end up with 1. In case you're wondering, why does that happen? Well, you're thinking a to what power gives you a? Well, a to the first gives you a, so it always equals 1. Okay? Log base a of 1 is what we saw in C and D. So it doesn't matter which base you have. If you're taking the log of 1, it's always going to equal 0, because anything to the 0 power gives you 1. So any base for your logarithm of 1 always equals 0. Okay? Last thing that we're going to do is graph some logarithmic functions. So logarithmic functions will look like that. F of x equals log base something. So let's do log base 4. So we have a number to deal with of x. Okay? What I would recommend doing is let's go ahead and change that f of x to a y, since we're going to have x, y coordinates. And just to make our lives a little easier, let's go ahead and change it to exponential form. So in exponential form, the base is 4, the exponent is y, and it equals x. Okay? So when I'm filling out a nice little x, y table, usually I start out with some x's, but this time I'm going to start out with y's, because the y's are in the middle of my function right now, okay? So how about we start out with some y's of -2, -1, 0, 1, and 2. Just some nice easy values to start out with. So if y is -2, that would be 4 to the -2nd power, which would be the same thing as 1 over 4 squared, which would be 1/16. If y is -1, that would be 4 to the -1st power, which would be 1 over 4 to the 1st power, so that would be 1/4. If y is 0, that would be 4 to the 0, and anything to the 0 power is 1. So 4 to the 0 is 1, so we'll have that point 1, 0. Let's see, if y is 1, that would be 4 to the 1st power, which is just 4. And if y is 2, that would be 4 to the 2nd power, which would be 16. So now we have some nice points to plot. I've got the point 1/16, -2, 1/4 -1, 1, 0, 4, 1, and 16, 2. And 16 is kind of off my graph, but let's just kind of count over to it. Here's 10, 11, 12, 13, 14, 15, 16, and 2. Okay. And I'm going to make a nice smooth curve to connect my dots, and this does continue, so we will use some arrows. And so what you'll notice is that on one end it's going to go towards the y-axis, and we'll never touch it, because what's going to happen is as y gets to be really, really big negative numbers, we're going to have 1/4 to a huge number, right? So we're going to have 1 over a really big number, which never quite gets to 0 for x's. But it gets very, very close. We're also never going to get a negative value for x, no matter what exponent you put in for y. So it's going to go towards the y-axis, okay? The other end of it just goes very rapidly to the right. It's going to kind of slowly increase and very much increase to the right, okay? Let's do another one. What if instead of a base of 4, what if I have a base of 1/4? Just to have something that's between 0 and 1 to see what happens with very small numbers, okay? So this would be y equals log base 1/4 of x, and in exponential form, we would have a base of 1/4, an exponent of y, and it would equal x, okay? Would you guys like to see if you can fill out a nice little xy chart? We'll use the same y values as before. -2, -1, 0, 1, and 2. Okay, so go ahead and pause your video. See if you can figure out the x values that go with it, okay? And I'll show you the answers in 3, 2, 1. Alright, you should get 16 for -2, 4 for -1, 1 for 0, 1/4 for 1, and 1/16 for 2. How'd you do? You do okay? Alright, if you haven't plotted it yet, let's go ahead and graph everything. So first one I have is 16, -2, and again, 16 is not on my graph, but let's just kind of count over to it. So here's 10, 11, 12, 13, 14, 15, 16, and -2 would be right there. Then I've got the point 4, -1, 1, 0, 1/4, 1, and 1/16, 2. And connecting my dots to make a nice smooth curve, what's going to happen is that I approach the y-axis again, but this time I'm approaching the positive y-axis instead of the negative y-axis. I'm still going very, very quickly to the right, but in my log base 4, I was going up and to the right. In my log base 1/4, I'm kind of going very slowly down and very quickly to the right, okay? So let's summarize that a little bit. So with these logarithm graphs, one thing you might have noticed is that both graphs contained actually one of the same points. It's right here. That point 1, 0 is in both of our graphs, so it always contains that point 1, 0, and that's just because anything to the 0 power equals 1, so the log base anything of 1 always equals 0. When a is bigger than 1, so that would be like our log base 4 of x graph, the graph increases from left to right. It goes up. When a is small, between 0 and 1, the graph always decreases from left to right. It goes down. The graph is always going to approach the y-axis, but it doesn't touch it. So the y-axis is called an asymptote. And then let's talk about the domain and range. So domain for both of our graphs, how far left did we go? We went right up to the y-axis without ever touching it. So we started at 0, and then we kept going to the right forever, so that would be infinity. And keep in mind that we do have a parenthesis at 0, because we don't touch that y-axis, we just get very, very close to it, okay? The range for both graphs, if you look at how far down do you go, well, let's see, this one went down very slowly, but it's going to keep going down forever. this one went down very, very quickly, and it's also going to keep going down for forever. So we'll start our range at negative infinity because it's going to keep going down forever. How far up does our graph go? Well, this one went up very, very quickly, and it's definitely going to keep going up for forever. The other graph, it went up slowly, but it's also going to keep going up for forever. So our range will be negative infinity to positive infinity. Okay. Hopefully this helps you guys with logarithms. Do lots of practice. I know that for a lot of you this is going to be new, but they're not that bad once you get used to them. Okay, so you guys can do this. Lots of practice, and good luck this week.